Hello, everybody, and welcome to our webinar where we are going to be discussing working with point clouds with Trimble and Tekla. On the line today, we have Lee Snyder out of Tekla Structures Group. Lee's a product manager over on the steel side, but also overlaps quite a bit on product development for concrete, rebar, and a few of the other segments there within Tekla. So a great resource to have on the line. We also have David Highland, a scanning specialist sales engineer with Trimble that has worked all over the world with a lot of our scanning customers and our scanning products. And myself, Ian Warner, product manager for the Field Technology Group. So before we get started, I just want to let you guys know we are going to be recording this webinar, and we can email that out to you once the session's concluded. If you have any questions, please go ahead and submit them through the questions tab. If we don't get to them on this webinar, we will respond back to you as soon as possible. So topics for this session, we're going to talk about common and costly mistakes for structural contractors. That includes concrete, specialty steel, and structural steel contractors. We also are going to talk about the Constructible process and the workflows we have for those structural contractors. We also have a Trimble workflow demo. So we're going to talk about the product portfolio, our scanning overview. We'll talk about Tekla, and Lee will show some of the new things coming out in 2020. And we'll also talk about our Sight Vision and Trimble Connect for HoloLens offerings as well towards the end. And we'll leave you guys with some references and resources to come ask questions at the end as well. So before we get going, I want to talk about Trimble Buildings and kind of the portfolio we've put together. We've really concentrated in the last few years on making truly constructible, connected, content-enabled BIM models that help us take projects all the way from concept model all the way through operations and maintenance. So we have estimating products that help for conceptual estimating, and we have conceptual modeling products as well, such as SketchUp and a few other products out there. We have really accurate data within our engineering and modeling platforms under the MEP and Structures group. We have a lot of that data we can take through all the way into construction and project management with products like Project Site and Viewpoint and eBuilder. And then we can take that all the way through operations and maintenance with Manhattan and some of the other products we have out there as well. So truly a one-stop shop where we can take a lot of your data and make sure that you're actually able to build from those models and from those drawings down to the nut, the bolt, the rebar level of detail. So that makes a huge difference when you're actually trying to put these projects together and get them built on time and under budget and with the quality everyone expects. So one of the backbones behind that whole process is connecting all the various data sources, and we basically have Trimble Connect to fill that void. So Trimble Connect is a really robust platform. We've written a lot of our programs to basically interface directly with Connect. There's several different versions. You've got a desktop version, you have a web version, we have mobile versions that you can take all the way down to your cell phone themselves. They'll also go out to our HoloLens and Sight Vision and other mixed reality, augmented reality devices. And so we're able to take almost any types of format in there. We're a very open, agnostic format, so we don't care if your products are coming or your projects are coming from Tekla or SketchUp or Autodesk or Bentley or whoever. We want to be able to view all that data in one location and take it to the next level. So one of the ways we're able to do that is we're able to federate all the different types of models together. So we can take structural from Tekla, we can take architectural from SketchUp, we can take some of the other models maybe from the other platforms. We can federate all those models together, so now you'll have architectural, structural, mechanical, electrical, plumbing, even some of your civil drawings all combined into one area, and then we can create views and section cuts and share those out with all the various team members. So a great way to collaborate not only on the design front, but also during construction and as you're making changes and as-builts and modifications to those models. We put it into a nice, easy-to-use format. You can basically dial in from any web browser anywhere in the world and help see your project and manage that project directly, either through your web browser or just down to your cell phone and on your mobile devices as well. Just a little bit about Tekla. Tekla Structures, Lee will get into more depth here, but this is just an example of some of the level of detail that we're able to get into in the Tekla models, and we're literally taking these down to the nut, the bolt, the fillet, the weld, the rebar, the bends on the rebar, anything that takes a structural load, we basically take down to that constructible level of detail in the 3D model. So that includes structural steel, concrete, precast, embeds, anchor bolts, even metal stud framing, wood stud framing. Tekla has some really robust formwork tools in there as well, so you can take it down to the formwork level of detail to show how you're actually going to build this project out as well. We even have quite a few contractors using this for aluminum curtain wall framing and other structural elements, so it really takes it down to that nut and bolt and screw level of detail. Also in the field technology group, we have a pretty robust portfolio there. So we have our field layout solutions that include robotic total stations, rapid positioning systems, GNSS systems, as well as really robust tablets that can take a beating out in the field and keep on ticking and bring you all the data right to your fingertips there while you're trying to do layout and be proactive on those building projects. We also have a pretty robust 3D scanning portfolio. David Highland will get into that here in a little bit with some of the new offerings as well. We've got mixed reality solutions, so we've got the XR10 for indoor capabilities and not direct sunlight, but able to augment your reality, have that mixed reality experience where you can still walk through your models and experience the entire project that way. We also have sight vision as well that David will talk about a little more detail here at the end. We also have personnel management on the job site through CrewSite. They've got turnstiles and badges and RFID beacons, and we can kind of manage and help out with the safety and security and reporting out on the job sites with that CrewSite personnel tracking. They've also added site cameras in there as well, so another great offering that we'll get into in another webinar. So without further ado, I'll hand it over to Mr. David Highland, and he'll talk about scanning.
Awesome. Thank you, Ian. Sorry. So yeah, I'm going to do a quick overview of the newest, I suppose, member to the Trimble scanning family. It's the Trimble X7. So I think there's a couple of buzzwords that we're using with the X7. Simple, like, for someone that's been in the scanning industry for many years, being able to pick up the X7 and kind of just go out and scan any project compared to the traditional days, the X7 really simplifies that entire workflow. You can literally give it to someone that has no experience whatsoever and be confident that they're capturing the correct data that's needed out of the project. Smart, what I mean by that is we've built in a couple of smart technologies into the hardware platform itself, such as the auto leveling, the in-field registration, which I'll go into a little bit more detail in some of my further slides. And then professional, what we mean by that is we want the scanner to work where you guys work, so regardless of the environments that you might be in, and to have that high quality data as well too. So making sure that the data that you're handing over on the back end is professional in that regard. So here's just a quick breakdown of some of the specs on the X7. Some of the key features that I'm going to talk about are up there on the top left-hand side of the screen. So the auto registration. So we have a feature in here called Trimble Assist. So what that uses, it uses the high accuracy IMU built into the scanner. So when you position the scanner out in the field, do your scan, and when you move your scan to you move the scanner to the next location, that IMU is tracking you as you're moving in the field. So it's allowing you to do registration live on the tablet. So one of the things I wanted to mention on here as well too. So this is paired with the Trimble T10 tablet, utilizing the Trimble FieldLink platform. So anyone that's familiar with the robotic total station layout or any of our GNSS platforms will be familiar with the Trimble FieldLink software. We also have the first scanner of its kind to have in-field auto calibration. So you're not having to send a scanner in for its yearly clean and cal or service. So you're not having to deal with extra rental costs because you don't have a scanner. So that's a huge feature that allows you to be a little bit more productive out in the field. Also with that, we are offering 2-year factory warranty with the hardware as well too, so some pretty pretty nice features built in there. The auto leveling, so it's a 3-second auto level compensator. So when you're doing your scans out in the field, if you're like focusing on floor flatness or FFFL values, the scans will come in extremely plumb relative to the real world, which is pretty important when you're comparing the point cloud to the 3D BIM model. And then the last feature that I'm going to kind of talk about is the laser pointer. So we've incorporated I suppose a laser pointer into the scanner to allow you to do in-field registration or georeferencing and do some basic layout as well too. So there are some of the main features that I kind of wanted to talk about. You can kind of do a quick glance at the rest of the other specs on the scanner, such as the environmental rating. It is IP55, so as I mentioned before, it will work in some of those harsh environments that you might be working in, and you can see some of the operating temperatures there as well too. Your average scan speed is a kind of about 3 to 4 minutes, depending if you're doing image capture as well too. So you can see down there in the bottom left, it's less than 1 minute for the high-speed image capture, which you'll see there, some of the quality of the images coming through. So not to forget about the rest of the scanning portfolio, we have a number of different platforms because not one scanner works on, I suppose, fits all. So you can cherry pick which one works for your project. So we have a number of different scanners, starting from the X7 all the way to the TX8. I suppose the main differences that you'll see there is the range on the scanners, and then some of the accuracies as well too, anywhere from the 3mm down to the 1mm on the TX8. So that's kind of a quick overview of, I suppose, the different platforms on the actual scanners themselves. As I mentioned, this is all combined with the Trimble T10 tablet, incorporating Trimble Field Link. I think one of the things I really wanted to focus on is the construction workflow. This software has been built for the construction industry, so we're very aware of what those needs are and the workflows that are required out in the field. We wanted to focus with in-field deliverables because, again, looking at traditional scanning, a lot of this was only possible back in the office. This was not viable in the field. So with these in-field workflows, we can do in-field registration and we can do in-field georeferencing. So this allows us to upload our BIM model straight to the tablet, and that could be PDF, it could be a Tekla file, it could be a DWG. We can literally absorb any kind of a file in their SketchUp as well. So it allows us to do this whole scan to BIM process in a much quicker turnaround time. So with some of the file formats that we can export directly out of the tablet, you're looking at some of your traditional ones such as the E57s, the TZF files. That's the native Trimble file that comes out of the scanner. These are the two files that we can take directly into Tekla Structures. You also have some of your industry standards there, such as the LAS files. If you're working with any of the Autodesk products, you have the recap file up there at the top. So again, as Ian mentioned, pretty standard file format. And then you also got the POD file there as well too for your Bentley, if you're working with any of the Bentley platforms. So I suppose before we kind of get into the workflow overview, I suppose why do we want to do 3D scanning? So you kind of see it now that's more of a demand in the industry. We want to be constructing these models or these buildings the way that they've been designed. One of the ways to do that very accurately is to use 3D laser scanning, so documenting the as-is conditions, making sure that everything is being constructed the way that it was designed. It allows us to track the progress of these projects, make sure that everything is being built in the right location, if we have any clashes, and so on. So it's a great, I suppose, verification tool out in the field. And so you'll see there, and then the image that you see there on the right is actually the TX6, just to kind of give you an idea of what the form factor of the TX6 looks like versus the 7. So before I went out to the field, Lee uploaded the project to Trimble Connect because this is the backbone the sharing the files. So we want to make sure that we're connecting the field to the office and back again. So once it's up there in the cloud, I can get a notification that it's being uploaded. Then I can import this directly into Trimble Fielding. So this is the interface that I see here on my tablet in the field. You can see I have a Trimble Connect tab. I just hotspot my phone, then I can download that file directly into my tablet, which you can kind of see here. I just have it in a wireframe mode. This allows me to create control points that you can see there that I have CP1 and CP2. We can do grid offsets. That's a 10-foot offset and 5 to the left of the project. So again, very, very flexible in the field. So once I've got that basis of the project set up, it's literally very simple. So you can kind of see one of our users here taking the X7 out of its backpack. So it comes with a really nice soft shell backpack, so you can get in on airplanes. So if you do a lot of traveling, you can also see it comes with 3 batteries. These are the exact same batteries that you would utilize with the robotic total station. So you can leverage some of those additional batteries if you're out on a large project. So we're cognizant of that as well too, to use what you have already in your portfolio. Use the exact same charger as well. So it comes with the Gitzo tripod as well. You literally place the scanner anywhere on the project. So very little kind of, I suppose planning needs to go into this. You just put your scanner up. Once you have your scanner set up, you also can get an accessory. Essentially, it's a black and white target that you can, attach to your regular survey pole. This allows us to shoot into control points. And you'll see the benefits of doing the in-field georeferencing, because typically your typical workflow would require total station to do this, or to, have a lot more workflows, or require someone that has a lot more technical experience. With the X7, we're doing all of this we're doing 2-in-1 essentially, and the workflow is extremely easy because anyone that had been using the robotic total station in the past, this will be very, very familiar to what they would be doing, setting up a total station for traditional layout in the field. So very similar concept. We shoot in that point, then that does a resection. So you can kind of see here's a quick illustration. We shoot in our 2 control points that positions our scanner then relative to our model. You can kind of see the little icon there. And then we just hit the scan button. Once you've hit the scan button, it takes you to your settings where you can say if we want to do HDR images, what kind of scan resolution do we want. Your typical scans that we were doing on this project were 3-minute scans with the 1-minute images as well too. So you can kind of see where we did our first scan, and then as I move the scanner throughout the project, it's using that IMU then to link in all my scans relative to one another. And then it's using the Trimble Assist, so the cloud-to-cloud overall registration, then to tie those in pretty tightly together. So you can kind of get a really good idea of the coverage that you've captured on the project. So you can kind of see up there on the left-hand side, just above Station 2, that there's a bit of a area where I could have done an additional scan if I needed. But again, this is great to see out in the field the coverage area of your project. Taking a little bit of a deeper dive into, the T10 tablet, what this workflow offers in the field. I'm just going to do a little bit of a deeper dive. So again, this is pretty amazing compared to, the traditional days of scanning, where you can have all of this information available at your fingertips on the tablet in the field. You can see here we have our point cloud with our 3D model. We've got the chain links between all our scans. This is a fully 3D coordinated model. If I rotate around here, you can kind of see the tower crane there. We can see they were pouring concrete as well too, so we can see how the frame was or the crane was moving throughout the project. So the scanner picks up a lot of detail in a very short period of time. Again, we can see that chain link, and you can kind of see the direction that we went on the project. So again, just giving us a bit of a good idea of the coordination. We can turn off these different models as well too. So if I want to turn off the 3D model and just look at the point cloud, I can do that by just clicking on these tabs. If I want to turn off my grid points, I can just turn off the points. Or if I want to turn off the point cloud and just look at my 3D model and now switch over to my RTS to do layout, I can do all of this from the one software. So again, just showing that integration. Here is the, I suppose, the 2D or 2.5D interface where we have the grayscale color images. We can also turn on the high resolution HDR images as well too, so you can kind of see the clarity that we're getting. We can zoom into this, we can read labels. So again, some very high quality images are captured with the X7. And then we can toggle between any of these stations out on the deck. So I can jump over here to station 7 and see exactly what the perspective the scanner was able to capture. And then I can blend all of those together into one panoramic image as well too by just hitting this HD icon. So you have that functionality there. Also, because we have that high accuracy tilt sensor, we can now also take accurate vertical measurements as well too. So this is kind of, I suppose, a critical component that you want to make sure your scans are coming in plumb. So we can see that vertical offset distance there between the two steps. And this allows you to take any measurement from any aspect in the field. So if we wanted to see the height offset between these two buildings, for example, I can easily do that in the field. So that's the Z-axis. We can also lock the horizontal axis as well too. So if I wanted to pick a point from the slab edge here over to the form over here, I can see that distance. If I wanted to do a point to point, so where I won't have the, I suppose, the horizontal fixed, I can pick these 2 points here, and then it'll give me that exact measurement. So again, a few button clicks, and I can get all of this information right out in the field where I don't actually have to go back to the office to process this. And then I can also turn on the high resolution color images as well too, if I wanted to kind of get some more clarity. One of my favorite features in here is to superimpose the 3D model over the point cloud, so now I can actually verify that the rebar is in the right location. I can kind of see that model superimposed over the point cloud as well too. Just give me that kind of, I suppose, warm feeling that everything is being constructed in the right spot. Also here, if you actually switch the point cloud to the intensity, we can also check the location of the embeds to make sure that the embeds are being built in the right location. We can kind of see here as well too how the model varies slightly differently to the edge of the, I suppose, the formwork and the 3D model. So again, a lot of information right at your fingertip. Some other functionality that we can do inside of the actual point cloud. If I just rotate around here just a little bit, and we just come over here to another side of the project, is we can verify or check things in the field. So this is a huge benefit for contractors to being able to do this now in the field, not having to go back to the office to get all of this information. So it looks like here we have a slight difference in change between the formwork and what the point cloud captured. So I'm going to turn on one of the section boxes I created earlier on so I can hide the crane tower, so we can kind of just crop out areas that we don't want to see in the point cloud. And if I do a top-down view and I lock in my 2D axis, I can see the formwork on the right-hand side is matching really well with the model, but I can see that there's a slight gap between the north side of the model. And again, if I wanted to take a quick measurement to this, I can come over here, I can create a point on the 3D model. So you have to create a point on the geometry if you want to do a measurement from the geometry to the point cloud. So I'll just create 2 points. Then I can click on my ruler, and then I can just click on the point cloud as well too. So I can kind of see that offset between those 2 points. So let me straighten up a little bit. So I can see that there as well. So this is a great way to as build out in the field with very, very minimum downtime. If I check the south side, I can see that it's fitting really nicely here. If I check this form edge here as well too, I can kind of see the point cloud working or coming together really nicely with the actual step there as well. So just kind of giving me that verification. Sorry, if I come over to here to one more section view, so one of the other features I just wanted to show in here was the ability to just randomly click on the point cloud. So we say if we had a trench or we're doing, wanted to do a quick volume calculation, I can just click on the 4 corners because this is where they were going to do the next pour on this project. So I'm just going to click on the 4 corners of the formwork, and you can kind of see it gives me all the lengths as well too, which is kind of great to see that as well, additional information. So I have the area of that. Now I can come over here and I can say that this is going to be a 7-inch pour. And then once I go back into my home screen, then you can now see the volume of that pour. So it's a great tool out in the field It's some huge workflow advantages. And then I suppose one of the last things I really wanted to focus in on is the ability to do a full refinement of the point cloud. So there was no need to, I suppose, export out the data to a desktop software. You have the ability to run the full refinement of the project on the physical T10 tablet, which gives a lot of, I suppose, benefits. You're driving home from the job, you can just hit refine, and your point cloud is fully registered. So typically, what the scanner is doing is tying 1 to 2, and then 1 is going into 3 and 4 and 5. So it's just doing that chain link. When we run the physical refinement, 2 is tying back into 3 and into 4 and into 5, and same way reverse 4 is trying to tie back into 2. So we're doing a full bundle adjustment on the physical data to give you a very, very tight registration, so you know your data is accurate and in the right spot. And then just before I hand it back over to Lee on the Tekla side, I'm just going to export out an E57 and the TZF file. So I'll give him both options just to kind of show that functionality. But this is the kind of the very powerful side of the workflow. When I export out this point cloud, because I've referenced this off of the initial model to begin with, when Lee brings it back into Tekla, the point cloud will come in the exact right location. So there's no second guessing that your point cloud is in one coordinate system and your model is in another coordinate system, which is probably one of the biggest headaches working with point clouds today. This really simplifies that overall workflow. I probably can't stress that enough. So once I export these two files out, I'll just upload these to Trimble Connect. Lee will get that notification on the back end to say that David's uploaded the point cloud. So you can kind of see here I've uploaded the E57 and I've also uploaded the TZF files as well. So he can kind of pick and choose which one he needs. But again, he just needs one of them. I just decided to upload both of them just because I had the time to play around with. So with that, I'm going to hand it over to Lee, and he's going to take it over from here on the Tekla side.
All right. Thanks, David. So picking up where David left off, what we want to do is bring that point cloud into the Tekla Structures model. And we've been able to import point clouds for quite a while. And as Ian mentioned during the introduction, we've added some new features in version 2020 to make handling the point clouds easier. So I just want to highlight those real quick before we jump into the model itself. One of the things that we've done is we've added the point size and density settings for improved clarity. So you'll be able to see that. You can see what we've done in previous versions there on the left, and then that the ability to change that and also show that in the model. So that's something that the users have been asking for a while, and we've delivered that in version 2020. The other thing that we also added is the ability to colorize the point cloud by clashes with the model. So we have this new clashes option that you can see down here, and then you can highlight the model objects, and then it will colorize the point cloud based on the tolerances that you define here based upon your project settings or your company's settings, just to make it real nice and easy to be able to do that. So for example, here we can see where these stair stringers would be intersecting with the existing model. And that way we know what to cut out and where we can put in the connections as we're tying into that particular project. So let's pick up where David left off. We're gonna jump right here into Tekla Structures. For those that may not be familiar with Tekla, what it is it's a one-to-one prototype of your project where you can come in and model in any level of detail that you need down to fabrication and erection level to be able to do that. So we have tools for modeling in steel members, beams, columns, plates, bolts. We can model in concrete beams, columns, slabs, footings. We have tools for automating the formwork, as you can see here, and any number of repetitive tasks can be automated there. We can view it in 3D or 2D, as you can see here, and then we can come in and we can interrogate the model. If we want to pull measurements, for example, we can do that. We can inquire on the objects to get the length, the weight, the area, the volume, that sort of stuff. So it's a 3D database of information here on your project. So what we'll do is come over here on the side pane to our point cloud side pane, and we want to go in and find that file that David uploaded. So I'm just going to go to browse, and here's the E57 file, but you can also see the other file formats that can be imported directly into Tekla. So we'll just use the E57 that David prepared, and I'll go ahead and click open. And then as mentioned, there's nothing that I need to do as far as locating this since it's geo-referenced, so I can just import this based on the model origin. If it is offset or if it wasn't geo-referenced, we do have a base point option to be able to manipulate that as if needed, but since David has geo-referenced that, all I have to do is just click attach the point cloud. And then what that will do is it will go in and insert that to where I can then come in and interact with that. So that just takes just a second here or so. So I'll just go ahead and turn that on. And then before we start doing the comparison between the model and the point cloud, which is one of the main benefits, we'll just go ahead and take a look again at the enhancements that we made to the point clouds in version 2020. So I'll just hide the concrete and rebar parts here within the model, just so that we can view these new visualization settings within the model first. So you can see that as we over here on the right hand side, we can control the size and the density. We also have those tolerances, which I'll show here in a minute. But as you zoom in, you can view all of the different openings and everything like David was just showing in Trimble Field Links. You can see the rebar, any of the information that was scanned out there on site. And of course, we'll look at that in a minute in relation to the model. But as you zoom in, you can see the depth of the model also that's captured, the formwork, the rebar sticking out there. And as you zoom in previous versions, since we didn't have the size or the density, we'd start to lose some of the clarity the closer that we got zoomed in here. So now as we come over here on the right and enhance the size, then it doesn't matter how close we zoom in or out, we'll be able to see that clarity, and that can all be adjusted in real time. So just making it nice and easy to view the data that's been captured in a usable way. You can see here as well, if we zoom in on the formwork, we can get the level of detail with the rebar that's sticking out there as well. So some really nice improvements. This is that I'm showing right now is 2020 beta that was released a few weeks ago. So you can go ahead and download and play around with that with the new features that are available there. So let's go ahead and turn on the model, and then we can start interrogating this point cloud in relation to the model, which is one of the primary benefits. So I'll go back into the display settings, and we'll just turn on all of the concrete and rebar, just like we were looking at before. Go ahead and hit modify there, and then now we have the point cloud with the model attached. And again, we can view this in 2D, 3D, so I'll just go ahead and set this in 2D, and we can just start zooming in and taking a look at areas. So David showed on his side, we have that concrete column and the rebar, how it was fitting inside, so we can take a look at that here. And this could represent anything. This could be anchor rods, base plates, whatever you scan, you can come in and just begin taking a look to see how things align and match up, see if there are any discrepancies. David highlighted the slab edge up in the north corner, so we'll go ahead and take a look at that there, and we can see the difference here within the Tekla model. As we zoom in, we have the ability to pull dimensions and all that sort of stuff as well. So if we did want to take just a quick measurement of that, we can just go to our measurement tool, choose vertical distance, pick the geometry. We can snap to any of the points within the point cloud, and then we see the distance that's off. So to show the visualization here for the clashes, what I'll do is just rotate around, and then I'm just going to create a point clip plane just to make it easier to view this. So we kind of reduce some of the noise of the point cloud that's there. And then all we have to do is just come in here and select one of the model objects and then choose that clashes option. And then it will instantly colorize the point cloud based upon the tolerances that we've defined. So you can see that red area there, it's out over the 5 inches, so it's colorizing in that color. We can look at it in a plan view again and see that. And then using the direct modification tools, if we want to modify the model to match what's out on site, I can just simply click and drag that, spin that around, And now we get the nice green color based upon this tolerance that we've defined for the project or for our company setting. So it all updates in real time and just gives you a nice visual heat map color to be able to understand the project in a better way that we haven't been able to do before. So we can remove the clip plane there. We'll go back to a plan view and we can take a look at some of these other openings if we want, again, to change the design model to match what was actually performed out on site so that we have an as-built version of the model. We can take a look at some of these openings. So again, if I click on the slab, it will then colorize those points based upon my tolerances. And if we want to adjust those, of course we can, just like we did on that slab that we were just looking at. So we can do that here for this bigger opening. So I can just click and drag that cut and just position it down, snapping to the point cloud. And then I'm tweaking and updating my model to match what was done out on site. And then to follow the workflow that we did before, if I want, I can then export this model, upload it to Trimble Connect, share that with David. And then now we have an as-built model matching that information. So that's just a quick overview of how that would work and highlighting these new features that are available in Tekla Structures version 2020. So if you want to take get updated information, you can follow us at the website, tekla.com. We're always releasing YouTube videos and additional content highlighting the new features that come out. So stay tuned to that if you want to learn more, or if you just want to learn more about Tekla Structures in general. We have solutions ranging from bridges to transmission towers to precast, cast in place, any type of steel structure. So you can go to that website and learn anything that you want. So at this point, I'll hand things back over to David and he'll take us through some of the virtual reality options that we have available as well.
Perfect. Thanks, Lee. So yeah, I'll take it back over here and I'll just touch briefly on Trimble's mixed reality portfolio. So you can kind of see here we have a couple of different options. The two that I'm going to really focus in on is our Trimble Side Vision, which is what you see there in the center, and then the new Trimble XR10 or the HoloLens 2 on the right hand side. So that's merging, I suppose, the digital world with the physical environment in more of a 3D immersive view. So looking at both of them in a little bit more detail. So if you're looking at the system component of the Trimble Side Vision, so it allows you to, I suppose, upload your digital content to the, I suppose, to this Android platform. So it's kind of bringing your own Android device, essentially. It's not supported on iOS systems right now, but at the top there we have an antenna, a GPS antenna, and that's using Trimble's Catalyst GNSS solution. So that allows you to incorporate high-end accuracy GNSS to your model. So when you walk out onto a project, it's anchoring your model very accurately to those real-world conditions. So you can upload anything from your structural engineering drawings to your concrete, any underground utility services as well too into that application. Then it uses either the VRS or RTX, so these are Trimble corrections that give you that high accuracy positioning out in the field. So we had the ability to take this out onto the same project that we did some 3D scanning. And you can see one of the users up there on the top right hand side where he has a pole mount as well too. So there's a handheld version and there's a pole mount. The pole mount allows you to go over a control point or go over the edge of an opening or something like that, and you tell the unit that this is where you're standing, takes a measurement, you walk over to a second point, and it takes a second measurement, then it orientates your drawing very accurately then to the real world, so you can superimpose those two, I suppose, the reality with the virtual world. So accuracy on this is about 2 to 3 inches. So again, it's to give you a pretty good idea of where everything is, or maybe you're missing something. It doesn't have the same accuracy as the I suppose the 3D laser scanners or the robotic total station. So it's definitely more of a kind of a quick QA QC tool. It allows owners to visualize, 3D aspect drawings in, I suppose, the real world. It's a great tool from that perspective. Here's just a little quick video of one of our users actually using it out on a project. So they uploaded some of the shuttering or the formwork. Here you can see how you can use I suppose, a cross-section cut to see how it's going to interact with the real world. We also have the transparency button on the bottom right, where you can kind of toggle that back and forth and kind of mesh those two worlds together. So if you haven't seen the side vision, I definitely recommend taking a look at that in a little bit more detail. And then the other thing I wanted to talk about on the other, I suppose, mixed reality portfolio is the new Trimble XR10. So we work really closely with Microsoft on this, where we've designed, I suppose, the only hard hat version with the HoloLens 2, and it's called the Trimble XR10. So it's fully OSHA certified. It comes with a lot of, I suppose, features it has the ability to have the flip up visor. So if you're either in a prefab shop and you need to flip up the visor, it gives you that functionality where you always don't have to take the hard hat off. It's also intrinsically safe. So if you work in any, areas that require that certification, you have that ability. So if you're working in some hospitals or oil and gas industry, you have that functionality. You also have the Bluetooth headset, so it allows you to hear audio out on the job site. So if you're doing additional coordination with maybe the detailers back in the office, you have that functionality to listen to them. So it gives you a nice, I suppose, ability to coordinate with other people on the project. So with those Tekla model, I had the ability to bring that into Trimble Connect. So here's just kind of a couple of videos showing the interface, so you can kind of see how it's able to map my hand. So for anyone that had used the first version of HoloLens, this the new functionality with the XR10 and Trimble Connect for HoloLens is immensely improved. The integration and working with the UI is so much easier. So here I'm just uploading the model that Lee had uploaded earlier on. I'm doing a quick mesh map. You can see how it's meshing the floor, where it allows me to, I suppose, anchor the model to the floor. And then here I have the ability to put my two hands out. I can scale, I can rotate, I can move the model all in a couple of little gestures. I suppose, version 1 of this, was about 4 or 5 different menus you had to go into. So we've really simplified that whole model process. You can, I suppose, from a coordination perspective, it's a very powerful tool, especially, if you're looking at an entire building or something very complex to coordinate or make design changes. It's great working with owners of a building to show them what their project is going to look like. If I try to scale it too much, it's going to ask me if I want to scale it 1-to-1. Obviously, this isn't the project, so it's kind of irrelevant just viewing it in a scale 1-to-1. But I can walk around and I can get a really good idea of what the project looks like, even without having to be there. And then the other aspect that we can do with this is any of the 3D analysis that we do. So for example, we did a quick heat map of the floor. I can actually save that as a SketchUp file and bring in a SketchUp file on top of my model. So you can see the red is showing you areas where it's high. I can do 3D measurements, so I can snap I suppose, a base point at the edge of my model, and then you can kind of see how I can pull that distance out from each pillar. So I can see 50 feet, 70 feet, up there where we're having some high areas, so that's at an 1/8 of an inch resolution. We can pull all of those distance and measurements in there. So again, the mixed reality, I think, is something that's really becoming very popular on the job sites, just helping people visualize their 3D data. So I think with that pretty much concludes our webinar. For anyone that's going to World of Concrete, we are going to be there. We'll have the Tekla team there, and we'll have the field technology group there as well too. So that's this February from 4th to the 7th. You can see the booth. We're at C4303 in Las Vegas. If you would like to see a little bit more in-depth demo or would like us to come out to a project that you might be working on and kind of try this out in real time, you can please go to the go.trimble.com /working with point clouds webinar. So please go to that if you want to kind of get more information. And from there, then I think if people have questions, please submit those. And I think we have a couple of minutes on the back end to answer any of those questions that we might have.
Perfect. Thank you, Lee. Thank you, David. We've got a couple questions here. I just wanted to go through these while we still have you guys on the line. So first one's for David. This one's talking about the X7. It comes with the T10 tablet for the point cloud options, but can it be used with a Kenai tablet?
Yeah, great question. So unfortunately, we don't support the Kenai with the X7, mostly because of the horsepower required to work with point clouds out in the field. So on the T10 tablets, we have a Core i7 processor built into it, so it gives you, a lot better, experience working with point clouds in the field. So the T10 tablet right now is the only device that's supported with the X7 scanner.
Okay, all right, perfect, thank you. Next one's probably for Lee. This is there a way to crop the point clouds and remove excess data from the original file?
Yeah, so when you import a point cloud into Tekla, you're not able to kind of author or edit any of the data of the point cloud. You can use clip planes like I showed before, the work area, to restrict what you see. But if there's, like a tower crane or something like that in there, you won't be able to do that in Tekla. However, on the Tekla warehouse, we do have the Point Cloud Manager, which is just a real easy to use tool, and it has some really basic cropping tools to where you can kind of clean it up a lot more and restrict some of the stuff that you're seeing, and then export that as a new version of the point cloud to import. If you need more robust options than that, then Trimble has Trimble RealWorks, where you can really do anything that you would need within there. So that's kind of what we recommend. The Point Cloud Manager, that's something that you can download on the warehouse. It's free. And then if you need something more robust, you could use RealWorks or anything else, I guess, Ian and David, that you would recommend.
Yeah, I think David's got another option there within Trimble FieldLink as well.
Yeah, so I suppose just to add to that as well too. So you saw earlier on, I was able to create some section boxes where I was able to hide the crane. You have the ability to, section out an area inside of Trimble FieldLink and then just export out that section. So if you wanted to, you say ignore all of the neighboring buildings that are caught, because the scanner is going to spin around 360 degrees, capture everything in that range. You can definitely hide that, because there's no point in sending that additional information if it's not going to provide any benefit to the guys back in the field. So yeah, you can definitely crop it as well to make it easier for the detailers back in the office.
Perfect. So the person asking that question, yeah, all sorts of options to basically section that point cloud down to just what you want to utilize. Next one's actually for probably David again here. The X7, how does it handle true north versus project north, and will it kind of square that up relative to the project somehow?
Yeah, so when you do your, if you look at it from kind of a broad stroke, if you don't have any control points, you didn't do any kind of georeferencing, there's a couple of ways you can do it. When you first complete a scan without being set up, you have the ability to, the software will automatically detect an axis in that scan, and it'll square your first point cloud up. Then you have the ability to rotate that 90 degrees, so you can say, hey, this is where I want my project north to be. So when you do your your second scan, third, so on, everything then is linked into that first orientation. You also have the ability to, set up the scanner like a total station, where you can aim the laser at a surface shoot in 2 random points. You don't even have to have physical control and say, hey, this wall line, this is what I want my axis to be. So maybe if it's at a skewed angle, at a 30 degrees angle, that gives you a huge workflow advantage when you're exporting that out, that you're not having to manually line it up back in the office. So you can kind of dictate all of that out in the field. And you can also manually rotate that point cloud as well too. So you have a lot of options at your fingertip to have it at plan north or shot in on a grid site coordinate system or just randomly placed. So
okay, perfect. Next one's probably for Lee here. This is, are there point cloud streaming options for Tekla instead of loading the large files on the actual machine that you have Tekla on?
Yeah, so you may have seen in our user interface for the point clouds, you can navigate to a file, or we do have a URL option where you can put in a URL. However, currently we don't have a way to produce the URL, but if that's something that you're interested in, it's a very hot topic for us around here. So if you are interested in that or want to try it, definitely reach out to us, me, Ian, David, and we can talk further about that.
Okay, perfect. All right, thank you much. Actually, next one's probably for you again. And is there a way to view point clouds in Trimble Connect?
Yes, so in Trimble Connect, what used to be called desktop, now being called Trimble Connect for Windows, you have basically that same point cloud side pane that you saw in Tekla Structures, where you can go in and import those. Currently, there's not a way to view them in the browser version or mobile, but again, if you have a need for that, again, it's something that we're looking at and investigating and wanting to learn more. So please reach out if that's of interest to you.
Perfect. All right, thank you much. We have another question here about software, and this is probably for David, on if we have anything that can help convert that point cloud to a 3D model if they're not already in Tekla.
Yeah, for sure. So another software that I think Lee mentioned earlier on was Trimble RealWorks. So Trimble RealWorks is our dedicated point cloud software. Has a lot of different functionalities, such as all the heat maps, kind of something similar to what Lee was showing, contouring, volume calculations, stockpiles, all of that kind of great stuff. Other features built into that are modeling capabilities. So if you want to model, a form edge, or you want to model some steel, whatever the case may be, it has that functionality to model those additional objects for you. So it's able to auto snap to the point cloud, and then you have the ability to export those out as an IFC and bring those directly into Tekla as well. So yeah, a lot of different automated modeling tools built into the RealWorks software. If you are bringing a point cloud directly from Trimble FieldLink into Trimble RealWorks, you would just use the TDX file, which was up at the top of that export list that I was showing you earlier on. That is the Trimble Data Exchange, and you would just drag and drop that file directly into the RealWorks platform. Everything is already registered. So you're kind of already hitting the ground running. You would just go straight into your modeling process. So
the auto classification tools should help out there quite a bit as well.
Yeah, so that's a great point. So one of the new features that they've built into RealWorks 11.2 is auto classification. So the newest one that they've built in there is the classification of steel. So imagine if you're going out onto a project. There's a lot of people standing on the structure. You've got equipment, you got cranes, you got a lot of stuff going on there. You have the ability to auto extract just the steel frame from the actual point cloud, and then just have those intelligent layers. So I could export out one layer as a steel layer. I could export out another layer as the physical ground. So then that gives me the ability inside of Tekla to turn those on and off, and kind of cherry pick which layers that I want to have turned on in the the Tekla platform model.
Perfect. All right. Well, I think that's about all we have time for on questions and answers here. So if you have some other questions we didn't get to, please make sure you submit those, or if they're still on the list, we'll get back to you guys as soon as possible. Want to thank you again for your time on joining us for the webinar today. Hopefully you learned some more about the new scanning operations and Tekla point clouds and how they're handling point clouds in Tekla, and a few of the other items within the portfolio. So thank you again for tuning in, and reach out if you have any questions, and we look forward to seeing you all soon. Talk to you later. Thank you.